Hello, good day and welcome to my channel. This is Enjoy Math with Mr. Austin. Today we'll be looking at solving the sides of a right triangle with a given side and a given angle. Now let's look at this triangle. Now this is a right triangle with one of the angles given as 34 degrees. And then one side given as 15 centimeters. Now the question here is calculate the lettered sides of the right triangle below. Now we can calculate the side A and side B using any of the three trigonometric ratios I introduced in my last video. So for now, let's begin by calculating the side A using this angle 34 degrees given and this side 15 centimeters given. So to calculate A, from the right triangle, the side A is the opposite of the angle 34 degrees. So A is opposite to 34 degrees. And 15 cm is the adjacent side to 34 degrees. So we use 15 cm and the angle 34 degrees to find A, where A is opposite 34 degrees and 15 cm is the adjacent side of the angle 34 degrees. Now, which of the three trigonometric ratios has opposite and adjacent? Opposite and adjacent. Remember your SOHCAHTOA. It is what? TOA, which is tan. Opposite over adjacent. TOA, which is tan, refers to opposite over adjacent. So now that we have been able to establish the fact that the trigonometric ratio we are to use is tan, we'll go further to express the values and solve for A. So we have tan theta, where theta is the angle, is equal to opposite over adjacent. That gives us tan 34 degrees equal to opposite over adjacent. The opposite is A over the adjacent, which is 15 centimeters. Now, the next thing we're going to do is to get the value of tan 34 degrees. What you simply do is to go to your four-figure table and go to where you have tangents of angles, where x is marked in degrees. X represents the size of the angle whose tangent you are looking for. Now you go under the column X and trace to 34. Then move to your right under 0 because the angle is 34 degrees, which means 34.0 degrees. So you move to 34 under X and go under the column to your right, which is 0.0. There we have tan 34 degrees as 0.6745. So in place of tan 34 degrees, the value is 0.6745 is equal to A over 15 centimeters. Now at this point, we are going to cross multiply. 15 cm will multiply this and A will multiply the imaginary one under here. So what we're going to have is A is equal to 15 cm multiplying this. So we have 0.6745 times 15 centimeters. When we multiply that, what we are going to have is A equal to 10.1175 centimeters. And then we approximate that, what we have is 10 centimeters or 10.1 centimeters. So we have gotten A to be 10 centimeters by our calculation. Now we'll go over to calculate the side B. Now you can either use the 10 centimeter you've gotten for A with the angle 34 degrees to calculate B, or you can use the 15 cm and the angle 34 degrees to calculate B. Now let us calculate the side B using the side given 15 centimeters and the angle given as 34 degrees. Now this B is the hypotenuse of this right triangle, and the 15 cm is the adjacent side to the angle given, which is 34 degrees. Out of the three trigonometric ratios, we are going to use cosine because it is the one that has the adjacent and the hypotenuse. Remember your SOHCAHTOA, CA, which is cosine, referring to adjacent over hypotenuse. We have the adjacent here as 15 cm, and we have the hypotenuse as B. So we say cos theta is equal to adjacent over hypotenuse, where cos theta here now is cos 34 degrees. So we write cos 34 degrees is equal to the adjacent, which is 15 centimeters, over the hypotenuse, which is B. Then at this point we are going to cross multiply. So B will multiply cos 34 degrees and 15 cm will multiply the imaginary denominator of 1, that is here. So we have B times cos 34 degrees is equal to 15 centimeter times 1. That gives us B times, what is the value of cos 34 degrees? We'll get that by going to our 4-figure table, looking under the column marked X, trace it down to 34, and step to the right to the column that is marked 0.0. And when we do that, we can see that the value of our cos 34 degrees is 0.8290. So in place of cos 34 degrees, we write 0.8290 is equal to 15 centimeter. 15 times 1 gives you 15. Then at this point, we'll see that this 0.8290 is multiplying B. What we are looking for is B. So B needs to stand on its own. For us to do that, it means we have to eliminate what is standing with B, what is multiplying B here. And we're going to do that by balance method. Since 0.8290 is multiplying B, the only way to get rid of it is to divide it. So we're going to divide both sides by 0.8920. That will take care of this 0.8290, leaving B on its own, and then it will be dividing on the other side. So we have B times 0.8290 divided by 0.8290 is equal to 15 cm divided by 0.8290. This takes care of this, and we are left with what? B on its own, equal to divide 15 by 0.8290. And that will give us the value of 18.0941 centimeters. And when we approximate that, we're going to get 18 centimeters. So the value of B is equal to 18 centimeters approximately. Now let us calculate B again using the 10 centimeter that we got from our first calculation to see if we will arrive at 18 centimeters. Now, since we want to use the side A, which is 10 centimeters, and the angle 34, let's look at the relationship of these sides to the angle 34. This side A, which is 10 centimeter, is the opposite side to angle 34. Opposite side. And the side B, which we are looking for, is the hypotenuse. Now we have opposite and hypotenuse. Opposite and hypotenuse. And from our SOHCAHTOA, we see that what we have is SO, which is sine, representing opposite over hypotenuse. So we are using sine. Remember that sine theta is equal to opposite over hypotenuse. Sine theta, theta in this case is 34 degrees. So we say sine 34 degrees is equal to the opposite, which is 10 centimeters, over the hypotenuse, which is B. At this point, we are going to cross multiply. Remember that we have an imaginary denominator of 1 here. So what we have is B multiplying sine 34 degrees and 1 multiplying 10 centimeters. So we have B times sine 34 degrees, which is equal to 1 times 10 cm. So 10 cm times 1. That gives us B times, what is the value of sine 34 degrees? Now we'll go back to our 4-figure table and get the value of sine 34 degrees. We simply go to sine of angles and go under the column marked X, which represents the size of the angles. Then we'll go move down to where we have 34, and then move to the right of 34 under the column where we have 0.0. That gives us the value of sine 34 degrees to be 0.5592. So we now have B times 0.5592, which is equal to 10 centimeters. Again, B is multiplying 0.5592. Now, we don't want this to occur with B. When we multiply, what we're going to have is 0.5592B. So this becomes the coefficient of B after we multiply. Now, what happens is that we need to get rid of that coefficient. Since it's multiplying B, the only way to get rid of it so that B can stand on its own is to divide both sides by 0.5592. So we have B times 0.5592 divided by 0.5592 is equal to the 10 cm we have on the right hand side divided by 0.5592. This takes care of this, and we are left with B equal to 10 centimeter divided by 0.5592. Now another way is to say, from this point, since 0.5592 is multiplying B, what to do is to take it to the other side of the equation. Now what happens is that since it's multiplying, when it gets to the other side, it becomes division. So B stands on its own, and 0.5592 goes to the other side of the equation to divide what you already have there, the 10 centimeters. That's what we have as B equal to 10 centimeters divided by 0.5592. When we divide that, we are going to have B equal to 17.8827 centimeters. And when we approximate that, what we are going to get is 18. Approximate this onto this. This is 8, which is more than 5. Take it as 1 and add it to the 7, giving you 18. Remember your approximations. So we have 18 centimeters. Now you can see that when we used 15 centimeters and the given angle, we got B as 18 centimeters. When we also use the side A, which is 10 centimeters, and the given angle 34 degrees, we got 18 centimeters. So you can see that no matter the one you use, you arrive at the same answer if you do your working very well. Now it's time to give you an assignment. Now the assignment is going to be a very simple one. I will still use this same triangle, but give you a different angle inside. So we have the right triangle here, the same as this, but the difference here is just the given angle. Here we have angle 34 degrees, but in this one we have the angle given here as 56 degrees. So you use any of the three trigonometric ratios to calculate A and B. And your answer will also be 10 centimeters for A and 18 centimeters for B. Good luck.